Students, today we are going to start second chapter in the fourth unit, that is hyperbolic functions. In this chapter also we have only formulas. Okay, what is hyperbolic function definition and formulas related to hyperbolic functions. No problems. Okay, no problematic problems. Only formulas only will come this term. Only short questions from this chapter. Okay, let us do definition. The expression, what is the hyperbolic functions? The expression e to the power of x minus e to the power of minus x by 2, this value, the expression e to the power of x e to the power of minus x by 2 is defined as, this value or this expression is defined as hyperbolic sine of x, and it is written as sin h of x. It is written as sin h of x, hyperbolic sine function. Like trigonometric functions, sin theta, cos theta, cosec theta, sec theta, cot theta, tan theta, we have hyperbolic functions for all trigonometric ratios. It is hyperbolic sine function. First one is hyperbolic sine function. The expression e to the power of x minus e to the power of minus x by 2 is defined as hyperbolic sine function. This expression value is called as a hyperbolic sine of x. It is denoted by sin h of x, where e to the power of x, in the first unit we discussed about e to the power of x. E to the power of x equal to 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial plus dash dash to infinity. E to the power of minus x equal to 1 minus x by 1 factorial plus x square by 2 factorial minus x cube by 3 factorial plus dash dash to infinity. Means odd powers of x becomes negative, remaining are positive. And here factorial means, suppose 3 factorial. 3 factorial means 3 into 2 into 1. We have to start with 3, decreasing 1 by up to 1. Suppose 4 factorial means 4 into 3 into 2 into 1. Suppose 10 factorial, 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1 up to 1. We have to start with number, and that value is called factorial. Okay, this is e to the power of x expression, e to the power of minus x is. Next, it is hyperbolic sine function. It is denoted by sin h of x. Similarly, the expression e to the power of x plus e to the power of minus x by 2 is here plus, in this minus here plus, e to the power of x plus e to the power of minus x by 2 is defined as hyperbolic cosine of x, that is cos h of x. Cos h of x, it is denoted by cos h of x, that is sin h of x equal to e to the power of x minus e to the power of minus x by 2, and cos h of x equal to e to the power of x plus e to the power of minus x by 2. Okay, these definitions will come in the exam as a short questions. Okay, please remember these two. Sin h of x equal to e to the power of x minus e to the power of minus x by 2, and cos h of x equal to e to the power of x plus e to the power of minus x by 2. Next, the remaining hyperbolic functions. Similarly, the hyperbolic tangent of x, it is tan h of x, denoted by tan h of x. It is sin h of x by cos h of x. Similarly, tan theta equal to sin theta by cos theta. Here also tan h of x equal to sin h of x by cos h of x. If you divide two values, means sin h of x value this one, and divide with cos h of x, sin h of x by cos h of x, e to the power of x plus e to the power of minus x by 2. 2 cancel, we get e to the power of x minus e to the power of minus x by e to the power of x plus e to the power of minus x. Okay, that is tan h of x equal to e to the power of x minus e to the power of minus x by e to the power of x plus e to the power of minus x. Next, hyperbolic cotangent of x means cot h of x. It is denoted by cot h of x, that is 1 by tan h of x, means its value becomes reciprocal, that is e to the power of x plus e to the power of minus x by e to the power of x minus e to the power of minus x. Numerator is plus, denominator is minus. Also cos h of x by sin h of x. Next, the hyperbolic secant of x. Hyperbolic secant of x equal to sec h of x. Sec h of x means 1 by cos h of x. Cos h of x value e to the power of x plus e to the power of x plus e to the power of minus x by 2. 1 by cos h of x means it will be reverse 2 by. Okay, it will come 2 by e to the power of x plus e to the power of minus x. The hyperbolic cosecant of x is cosec h of x denoted by cosec h of x, that equal to 1 by sin h of x, that implies equal to 2 by e to the power of x minus e to the power of minus x. Okay, these 6 are hyperbolic trigonometric functions: sin h of x, cos h of x, tan h of x, cot h of x, sec h of x, cosec h of x. Okay. Next, related formulas. And sin h of x is e to the power of x minus e to the power of minus x by 2. In the first slide, we discussed about e to the power of x and e to the power of minus x. We have to subtract them and divide it by 2. We get sin h of x expression, and if you add both 2 and divide with 2, we get cos h of x expression as like this: sin h of x equal to x by 1 factorial plus x cube by 3 factorial plus x to the power of 5 by factorial up to infinity. Next, cos h of x equal to e to the power of x plus e to the power of minus x by 2 equal to 1 plus x square by 2 factorial plus x to the power of 4 by 4 factorial plus dash dash up to infinity. In sin h of x, only powers are odd powers 1, 3, 5. Here 0 power 0, x power 2, 4, 6 like this. Okay. Next, we will see the formulas depending on these hyperbolic functions. So first one, sin h of minus x equal to minus sin h of x, cos h of minus x equal to cos h of x, tan h of minus x equal to minus tan h of x, cot h of minus x equal to minus cot h of x, sec h of minus x equal to sec h of x, cosec h of minus x equal to minus cosec h of x. Means it is similarly sin of minus theta minus sin theta. Only cos of minus theta cos theta and sec of minus theta sec theta. Like this, here also cos h of minus x equal to cos h of x, sec h of minus x equal to sec h of x. Both are only positive, remaining are will come negative, like trigonometric function. And sin h of 0 equal to 0 and cos h of 0 equal to 1 and tan h of x 0 equal to 0. Because how means sin h of 0 equal to 0 means substitute in that e to the power of minus 0, e to the power of 0 by 2. E to the power of 0 is 1, 1 minus 1, 0, 1 minus 1, 0 by 2. 0 by 2 means 0. Here cos h of 0 means it is 1, it is 1, 1 plus 1, 2 by 2 means it is 1. Like that it will. Okay, next. Formulae of hyperbolic functions. Fundamental formulae. First one, cos h of square minus sin h square x equal to 1. Cos h square x minus sin h square x equal to 1. In trigonometry, for trigonometric ratio, sin square theta plus cos square theta equal to 1. But here, cos h square x minus sin h square x equal to 1. Slightly difference. You have to remember this difference. Okay. Next, second one, sec h square x plus tan h square x equal to 1. Or this can be written as if tan h square x comes to RHS, 1 minus tan h square x equal to sec h square x. Next, cot h square x minus cosec h square x equal to 1. If this 1 goes to this side, cot h square x minus 1, cosec h square x comes to RHS cosec h square x. These three are fundamental formulae. Next, sin h of x plus or minus y means sin of a plus b formula like that. sin h of x plus y equal to sin h of x plus cos h of y plus cos h of x plus sin h of y. If it is a minus, if you take, we have to take minus. Okay. Cos h of x plus y equal to cos h of x, cos h of y plus sin h of x into sin h of y. Cos h of x minus y, cos h of x into cos h of y minus sin h of x into sin h of y. Means if plus unte plus, minus unte minus here accordingly. Tan h of x plus y equal to plus or minus plus y equal to tan h of x plus tan h of y by 1 plus tan h of x into tan h of y. If you take minus, here also both the terms must be numerator denominator minus. Okay. Total 6 formulas. Next, sin h of 2x. Sin h of 2x equal to 2 sin hx into cos hx. Okay, sin h of 2x equal to 2 sin hx into cos h of x. Cos h of 2x equal to cos h square x plus sin h square x, or 2 cos h square x minus 1, or 1 plus 2 sin h square x. Any formula, any three. Any one of these three can be as a used as a formula. Same sin to theta, cos to theta, tan to theta. Akkada ela formulas unnayo, here also same, but slightly different. Tan h of 2x equal to 2 tan h of x by 1 plus tan h square x. This is sin h of 2x, cos h of 2x, tan h of 2x formulas. Next one, sin h of 3x, sin 3 theta formulas like sin h of 3x equal to 3 into sin h of x plus 4 sin h cube x. Cos h of 3x equal to 4 cos h cube x minus 3 cos h of x. Tan h of 3x equal to 3 tan h of x plus tan h cube x by 1 plus 3 tan h square x. These are tan 3x, sin h of 3x, cos h of 3x, tan h of 3x formulas. Next, inverse hyperbolic functions. Suppose if sin h of y equal to x, sin h of y equal to x, then the y is called hyperbolic sine inverse of x. Hyperbolic sine inverse of x, and is written as y equal to sin h inverse x. And ఈ sin h అనేది this side goes to this side, it will become say inverse y equal to sin h inverse x, inverse hyperbolic sine function, or hyperbolic sine inverse of x. Okay, sin h inverse x, inverse hyperbolic sine function, sin h inverse x. ఈ y ని ఏమంటాం? sin h of y equal to x. If sin h of y equal to x, then this y is called hyperbolic sine inverse of x, and it is denoted by sin h inverse x equal to y. Means y equal to sin h inverse x. This goes to this side, sin h inverse of x will come. In trigonometry also we have inverse trigonometric functions, sin inverse x, cos inverse x, trigonometric ratios. There we will discuss in the next chapters. Okay, inverse trigonometric functions will come in the next 6th unit. Okay, here only inverse hyperbolic functions. Okay, similarly we can define cos h of h inverse x, tan h inverse x, cot h inverse x, sec h inverse x, and cosec h inverse x. Okay, if sin h of y equal to x, then y is called hyperbolic sine inverse of x. It is denoted by y equal to sin h inverse x. Sin h inverse x, that value is y. Sin h of x equal to sin h of y equal to x, then this y is inverse hyperbolic function, sine function of x. Okay. Next, for inverse hyperbolic functions we have formulas. Remember these formulas as in terms of logarithm. Sin h inverse x equal to log of x plus square root of x square plus 1. Okay. Sin h inverse x equal to log of x plus square root of x square plus 1 and cos h inverse x equal to log of x plus square root of x square minus 1. Again, cos h inverse x equal to log of x plus square root of x square minus 1. Next, third one, tan h inverse x equal to 1 by 2 into log of 1 plus x by 1 minus x. Tan h inverse x equal to 1 by 2 log of 1 plus x by 1 minus x. Next, remaining hyperbolic functions formulas. Cos is over, tan is, sin is also over. Next, cot h inverse x equal to 1 by 2 log of x plus 1 by x minus 1. For tan, numerator is plus and denominator is minus. Here cot is reverse, x plus 1 by x minus 1. And sec h inverse x equal to log of 1 plus square root of 1 minus x square by x. 1 plus square root of 1 minus x square by x log. And cosec h inverse x equal to log of 1 plus square root of 1 plus x square by x. Cosec h inverse x equal to log of 1 plus square root of 1 minus x square by x. Okay, these are hyperbolic inverse trigonometric functions. Sin h inverse x, cos h inverse x, tan h inverse x, cosec h inverse x, sec h inverse x, cot h inverse x. Okay. In this class, we discussed about hyperbolic functions, sin h of x. We defined and discussed properties about hyperbolic functions, sin h of x, cos h of x, tan h of x, cot h of x, sec h of x, cosec h of x, and some formulas. Okay, identities, fundamental identities. Next, h of 2x formulas, h of 3x formulas. Okay, and inverse hyperbolic functions, sin h inverse x, cos h inverse x, tan h inverse x, cot h inverse x, sec h inverse x, cosec h inverse x, and inverse hyperbolic functions in terms of logarithm formulas. Okay, these formulas and identities and definition by at remember this one. These questions will come as a short questions, no problems. Problems does not come in this chapter, only formulas, direct formulas. So remember, and this chapter only comes short questions only. Okay, and complete the fair notes. Okay, up to till in the fourth unit we have remaining only one chapter, complex numbers. Okay, up to till you have to complete these fair notes, and any doubts please feel free to send message or call to me. Okay, next class we will start next chapter, complex numbers. Thank you.